Hello 8th grade algebra students. Today in this video we're going to be reviewing exponents, going over those a little bit. We're going to be answering a couple of questions that came up in class, a little more in depth, so you guys don't get confused. We're going to be going over polynomials, how to add, subtract, and multiply polynomials. We're going to be defining exactly what a polynomial is, going over some real-world uses. We're going to be checking that our operations do indeed work, that once you take two polynomials, add, subtract, or multiply them, that it is a way to simplify those expressions, that it's not just magic that's happening, that you're actually going to get the same answer after you've simplified if you were to plug values in for those variables. And then we're going to go over factoring. So let's jump right into exponents. The first thing I want to do is I want to talk about where exponents come from really quick. They were originally developed by mathematicians as like a shorthand notation, probably around 1500, but nobody really knows. So, easy things like 7 squared can easily be written as, 7 times 7. That's pretty simple, but the reason why mathematicians came up with exponents is, what if you wanted to take 9,999,999 and then multiply that 17 times? I think you would agree that would be a little tedious to multiply that number out 17 times. So that's kind of where exponential operations, came about. So then where did these laws come from that you guys have been studying in the past weeks in the classroom? Specifically just for this video, to keep it short, we'll focus in on, multiplying like bases with exponents, since it kind of directly applies to polynomial simplification. So, mathematicians looked at this and they said, well, this is pretty intuitive. If you have 7 squared, and you multiply it by 7 squared, well, that's just the same thing as saying 7 times 7 and 7 times 7 and then multiplying them. And what do we know about exponents? That's the same thing as saying 7 to the 4th. Well, this actually applies to any like bases, like 7 or x squared. You could break that down into x times x, multiply that, let's say x to the 6th, and then if you wanted to write that out, x times x times x times x times x times x. Let's see, let's count here. Let me double check. 1, 2, 3, 4, 5, 6. And you can see that this multiplied by that gives you how many x's? Well, that would be x to the 8. So that's where this law comes from. It's just, you can just add 6 plus 2, which will give you x to the 8. So really what all this is saying can actually be applied to any of the exponential laws. They're not lies. Like say if you had x times y squared, you can see that if you multiplied x times y times x times y, you can rearrange those as x times x times y, which is the same thing as x squared, y squared. So what you did is, you've got a 1 exponent here, a 1 exponent here, and you multiplied the 2 by the 1, which gave you this answer, but this is a breakdown of it and why it works. So you can break down any of these exponential law problems like this and break them down into their base parts, like what is this really saying? And you can derive the law yourself. You don't even have to memorize, what it is. Like if I forget that if I multiply x squared times x to the 6th, man, do I add or do I subtract or do I multiply? Well, let me think about it. I can do x times x. Okay, that's pretty simple. And if I multiplied that times x times x times x times x times x times x, well, that's pretty simple. That all just combines. Well, how many x's do I have? Well, that's x to the 8th. So now let's jump right into some of the questions from class that I thought were really good. So when subtracting polynomials, a student in the class that I was teaching had the question of, when you distribute this negative inside here, this turns into positive. Well, why does that happen? And I guess the easiest explanation would be, let's say you had the same expression, same polynomial. Wouldn't a minus sign be the same thing as multiplying a positive 1 by a negative 1? 2x squared minus y minus 8. So now I can distribute this negative 1 inside the parentheses. So let's go ahead and do that. This would go to a negative 2x squared plus y plus 8. So now that we've distributed this negative 1, it's gone. But look at what I still have here. I still have a positive 1. So now the polynomial subtraction equation is plus that expression, which makes it a little bit easier to solve. You really don't have to do that, though. You could have just subtracted like terms. I have my x squared here. If I minus a 2x squared, it's going to give me the same thing as if I had x squared here plus a negative 2x squared. So let's go ahead and do this operation. And when doing this operation, this one's pretty simple, but just get in the habit, because when you get into higher degree polynomials, it's usually good to rewrite it with the like terms beside each other. And, keeping all your signs in place. Plus 4, plus 8. So these are constants. They can be added together. These are the same term, like terms. And these are the like terms. So now all you do is simplify. X squared minus 2x squared goes to a negative x squared plus 2y plus 12. And that would be your simplified answer. Now the other question from class that arose that I tried to explain to you guys on the spot was, we have a law that states that this exponent here can multiply into these exponents, and this would go to x to the 4th, y to the 4th. So why is that? Well, we talked about it just a minute ago, and let me get my pen out here. Okay, so this is the same thing as saying x times x times y times that same expression again, the same equation. And this here is a monomial. Okay, this is one term, even though there are two variables. Okay, so you can rearrange all of these, x's and y's to anything you want, because it's still going to give you the same value no matter what you plugged in for x or y. So then that would be the same thing as writing x to the 4th, y to the 4th. And that's what our law states that you can do with that exponent in that case. Well, let's get this out of the way here. Let's look at the second expression, which is a binomial. It has two terms. Even though this is a constant, this is another term. If we break it down the same way, this is the same thing as saying x plus 4 times x plus 4, because we can't simplify this at all like we did over here. We cannot rearrange these terms because we don't know what x plus 4 is. And this is when you do your FOIL method, which is your first term times your first term, and then your outer term times your outer term. Let me actually use a different color for that. We'll change colors on this. So we're going to do our first term times our first term. And then we're going to do our outer term times our outer term, right? And then let's go blue. And then we're going to do our inner term times our inner term. Call this I. And let me make this a little more clear here. Apologize. So I'm going to bring these down. So our inner term times our inner term, I. And then, last but not least, we have our last term times our last term. And this is where this acronym comes from right here. FOIL. So, what do we get when we do that? We're going to do first times our first, which gives us x squared. Our outer times our outer, plus 4x. Inner times our inner, plus 4x. And then our last term times our last. So the plus 16, simplified down, plus 8x, plus, whoop, pen went crazy there, plus 16. Okay, so now we've kind of gone through the questions from class, so let's talk a little bit more about polynomials and what they are. So a polynomial is, so we have two terms here that are kind of useful, and this is a monomial and polynomial. So what you've looked at so far with your exponent problems have mainly been monomials, which is a single term, which can be like in the form of 4 times x times y, or something like 4x squared y to the fourth c squared. You can have any number of variables, but it's usually, or I should say it is always the case that your all of your exponents are going to be whole numbers. And that brings us to polynomials. And what these are the addition, subtraction, or multiplication of two or more monomials, but not an infinite number. So let me get my pen out over here. And I'll also say real quick that also just a constant number, because you could say, this is a whole number exponent right here, that would also be considered a monomial. So now let's look at a polynomial. Could be in the form like 4x plus 12, or you could have 3x squared plus x plus 12. So if you look at these are all monomials. This is one term, and a monomial, another name for that is just a term. So this is a term and this is a term. So you have two terms, therefore making that a polynomial, which in Greek poly means multiple. And in this you would have three terms, or three monomials, added together. And there's two cases where something is not a polynomial. Actually, I should say three cases where something is not a monomial or a polynomial. And it is using some things that you've dealt with before. And so if you see any variable raised to a negative exponent, any negative exponent, that is not let me emphasize this, not a polynomial or monomial. Or monomial. And this also goes for fractional exponents. So if you have the square root of x, or x to the 1/2, this is also not a monomial. And then the third case is if you have a variable in your denominator. This again is not a polynomial or monomial. Okay, so now I promised y'all I would talk a little bit about some uses of polynomials. So really, I've already wrote this stuff down for you. Finance and economics uses them greatly. Graphing things with a curve and showing growth of an account over time. Physics, modeling the way things act in the environment. Minus wind resistance and some other things. Polynomials greatly used there. Architecture used greatly as well. Also, this is where you're going to see it the most. Higher level math and engineering. And I know some of you aren't going there, but you never know where life takes you. And this stuff is really useful, especially in the finance category, for your own personal self, no matter what you wind up doing in life. Whether art, if you want to be able to figure out the compound interest, on an investment you made, polynomials are going to do it for you in finance. So, and who knows? You may be wanting to be an artist now, but then you wind up becoming a physicist or an architect that deals a lot with art too. And the last thing I'm going to talk about, and we're going to do more of the factoring review on the review day, Thursday in class, instead of doing it in the video, so I won't take up any more of your time. Right now I just want to show you all real quick that this addition, subtraction, and multiplication of polynomials does actually work, and I've already wrote this out just to save you all a little time. You can pause the video and look at it. I'm just going to talk over it real quick. We're going to check addition. So let's say I have these two polynomials here, and these each have two terms, so they are binomials, and I wanted to add them together. So let's just give x and y some arbitrary value, x equals 1, y equals 2, and plug them in. And that's going to give me an answer using good old PEMDAS. I don't know if you guys know that acronym or not, but it stands for parentheses, do all operations within the parentheses, then handle your exponents, and then your multiplication, which is right here. So you would have multiplication there. DOS, hang on, let me think about it. Division, and then last but not least, addition and subtraction. So doing all that, you would see that obviously you would take 1 squared before multiplying the two, because that would actually change what the end problem would look like. So you're always going to do your exponents before your multiplication. Just wanted to harp on that real quick. So 3 plus 2 minus 4 is 1. Now let's simplify this same addition of polynomials up here, and let's put it down here. And you guys can check that and see that it is correct. It simplifies to 2x squared minus y squared plus x plus y. And if we plug in our same values for x and y, we come up with the same exact answer. So you can see that the simplified version of this is actually equivalent to the addition of it. And finally, one last thing, let's check the multiplication. So I did a simple one here, two binomials again, but this would actually be, this could be called 2x plus 4 squared, right? If you took that out. So let's go ahead and let's let x equal 1. If you do 2 times 1, you wind up here with 6. And that kind of looks like a subtraction, so I'll make that clear. That is multiplication. 6 times 6 is 36. So now if we simplified this using our FOIL method, we get 4x squared plus 8x plus 8x plus 16. And then if we plug our x equals 1 into that equation, lo and behold, look at that. It also equals 36. So we actually check this, and it does work. And that is a way that you can check to see if you simplified these correctly. If you can plug some arbitrary number, let x and y equal something, into your polynomials, you can check them that way. Thanks for watching the video. I'll see you guys on Thursday.